Welcome back to 3 Inquisitive Kids. In this video, we will be learning about the perfect square formula. This is part 1, Introduction into the perfect square formula. Again, this is our course outline for chapter 7. Today, we're going to be learning about our second formula, and in the last lesson, we learned about the square difference formula. Our learning goals for today is to understand the derivation of the perfect square formula. And so see the step-by-step proof of this formula and see how we got this formula in the first place, and be able to use the perfect square formula to solve problems. What formula do the following diagrams represent? It's the square difference formula. A plus b times a minus b equals a squared minus b squared. So this formula is telling us how much is the shaded area of these two diagrams. So in the first diagram, it would be a squared minus b squared. And then here, it's a plus b times a minus b. This part is the a minus. And since we know that these two shaded areas are the same thing, we can put in an equal sign to get our formula. There is a square plot of land for field experiments with a side length of a meters. Its side lengths are increased by b meters, which results in a larger square made up of 4 small rectangles. Can you find a formula from the calculating the area of this land? So this is our square plot of land with a side length of a meters. And now we're going to increase its side lengths by b meters. And now we're resulting in 4 small rectangles. So we know that the total area would equal a plus b times a plus b. And if we look at this another way, we can find the individual areas of these 4 small rectangles and then add it together. A squared plus ab plus b squared. And since we know that the total area of this entire rectangle is the same thing, since we're dealing with the same piece of land, we can put an equal sign over here to come up with a formula. The sum of a and b squared equals a squared plus 2ab plus b squared. Calculate the following equations. Can you find any patterns? For the first one, we have p plus 1 squared. That's the same thing as p plus 1 times p plus 1, which gives us p squared plus 2p plus 1. This is what you'll get after you simplify and combine like terms. For the second problem, we have m squared plus 4m plus 4. Third problem is p squared minus 2p plus 1. And you can see that now we have a negative sign, p minus 1. And our last one is m squared minus 4m plus 4. But if you think about it, minusing or subtracting a number is the same thing as adding its additive inverse. Here we have p minus 1, but technically we can still use a perfect square formula if we look at it like this, p plus negative 1. Can you write down a formula based on your findings? We can conclude that a plus b squared equals a squared plus 2ab plus b squared, and if we have a minus b squared, we would get a squared minus 2ab plus b squared. Here's a geometry approach. Here we have our little diagram. This is a squared. The area of this rectangle is AB. The area of this rectangle is AB, and the area of this square is b squared. We add them together. Added together would equal the entire area of this square. So this is the sum of squares formula. A plus b squared equals a squared plus 2ab plus b squared. Here we have another square. It's a large square with side length of a, so its area would be a squared. And if this side length is b, this side length is also b, then this part would be a minus b. This entire part, this gray part, is ab. This is b times a minus b. This is a minus b squared. So what we're doing right now is we're trying to find the area of this blue square in the inside. And in order to do that, we have to subtract all the other rectangles from the entire area. So that's how we got a squared minus 2ab plus b squared. This is the difference of squares formula. A minus b squared equals a squared minus 2ab plus b squared. Now I want you to use the perfect square formula to compute this expression, 2x minus 3 squared. Our solution is to use the perfect square formula. So we get 2x squared minus 2 times 2x times 3 plus 3 squared. In this case, our 2x is the a, our 3 is b, and so on. You can compare this expression to the perfect square formula in order to make calculating easier. So these arrows are telling us what these terms correspond with to the formula, and we're left with 4x squared minus 12x plus. Here we have y plus 1/2 squared. This is our solution. We get y squared plus 2 times y times 1/2 plus 1/2 squared. And you can see that these highlighted terms are corresponding to each other. And we're left with y squared plus y plus 1/4. Think, does a plus b squared equal negative a minus b squared? I want you to do your answer. So first we have to break apart negative a minus b squared. This would equal negative a squared minus 2 times negative a times b plus b squared. And if a negative number is multiplied to itself, then we're going to result in a positive product. So negative a squared is the same thing as just positive a squared. And here we have two negative signs, a negative 2 and a negative a, and that combines to get us a positive sign. So it's plus 2ab plus b squared. And that is still the same thing as the sum of a and b squared. So yes, this does equal this expression. And now we're going to break apart b minus a squared. So this is the same thing as b squared minus 2ba plus a squared. If you think about it, they just rewrote the original a as a b and they rewrote the original b as an a. It doesn't do much difference. And now all you have to do is use the commutative properties of addition and multiplication to swap some of the variables around, and we're left with a squared minus 2ab plus b squared. It's still the same thing, a minus b squared. And does a minus b squared equal a squared minus b squared? So some people might confuse this with the square difference formula. That's what we learned in the last lesson, because this looks very much alike to the square difference formula. But this is actually not necessarily true. The equation a minus b squared equals a squared minus b squared is only valid when b equals 0 or a equals b. I want you to compute this expression. So our solution is to put in some brackets and parentheses ourselves. You can see that we've split this into x plus parentheses 2y minus 3 times x minus parentheses 2y minus 3. Here we have an addition sign, and here we have a subtraction sign. Now we're going to look at these parentheses as a whole, because that's what parentheses help us do. They group things together. So now we're technically left with two polynomials that each have two terms. One of the terms is x, and one of the terms is 2y minus 3. Now we're going to apply the square difference formula. I know today we're learning about the perfect square formula, but we have to get used to using the square difference formula and the perfect square formula without getting confused. So we're left with x squared minus the difference of 2y and 3 squared. And now we can use the perfect square formula in order to simplify the parentheses. We're left with x squared minus 4y squared plus 12y minus 9. So method summary. Grouping is required for solving this problem. We are used to having parentheses already there in problems, and it was our job to get rid of the parentheses and simplify. But now you have to be creative and add on parentheses yourself. And when you're adding parentheses, you can look at the term's signs. Here, we wanted to use a square difference formula, and we knew that it had to be a plus b times a minus b. And you can see that both terms had to be the same, but the signs had to be the opposite. So how could we do that? In this case, they didn't just randomly group the x and 2y and x and negative 2y together. They wanted to make sure that signs were different. So that's how they knew to group things together. Here we have a plus b minus 5 squared. Again, we have to add in our own parentheses. We're going to look at a plus b as a whole. So we're going to apply the perfect square formula and get a plus b squared minus 10 times a plus b plus 5 squared. Now we have to use the perfect square formula again in order to solve the first term. We get a squared plus 2ab plus b squared minus 10a minus 10b plus 25. Grouping is also required for this problem. We need to practice being able to look at multiple terms and thinking of it as a whole. Given 36x squared plus m plus 1 times xy plus 25y squared is a perfect square formula, find the value of m. Solution. Because 36x squared plus m plus 1 times xy plus 25y squared equals positive negative 6x squared. Remember, it's not just positive, it's also negative. Plus m plus 1 xy plus positive negative 5y squared. We kind of reverse this 36x squared and this 25y squared. And now we're trying to find what's our a's and what's our b's in the perfect square formula. M equals 59 or negative 61. In this case, a is positive negative 6x and b is positive negative 5y. To some math problems as you get older, there will be more than one answer, and most likely one is positive and one is negative. Class summary. Today we learned about the perfect square formula, and we did a lot of practice. The formula is a plus negative plus b squared equals a squared plus 2ab plus b squared, or a minus b squared or a minus b squared equals a squared minus 2ab plus b squared. And I want you to remember to transform an expression to look like the perfect square formula using parentheses and brackets, and be able to use the perfect square formula and the square difference formula without confusing the two. So in some problems you have to first apply the square difference formula, let's say, and then apply the perfect square formula, and you don't want to get those two confused.